assessment of the quality of measurement devices is carried out according for the following main indicators: sensitivity, range, accuracy, age of calibration, stability, frequency range, absence of noise and on-end signals, and ease of use. The purpose of the article is to analyze the quality indicators and the characteristic of temperature sensor based on semiconductors, diodes, and transistors, and formulate conclusion and recommendation for the practical use in the manufacture of electronic thermometers. To achieve the goal, the following task must be solved. First, analyze the thermometer from the point of view of their stability for monitoring temperature fluctuation of the surface of a biological object. 2. Investigate and dependence for the resolution of thermometers of different temperature range. 3. Determination of the dependence of the speed of the thermometer on the mass of the sensors. And 4. The study of thermal resistance of the transduced as an important of the characteristic effects of the international salt.
Valentin, sorry for interruption. You don't switch your slides. We hear only your title slide. Oh, Caesar.
So we don't see my presentation.
Oh, we see your presentation, but you don't switch your slide already. Now we see the second slide.
Yes.
Yes, second slide. Now, in the third three slides, we can see the common types of electronic thermometers are contact thermometers. There are three subclasses of contact electronic sensors. This is resistance thermometers, semiconductor thermometers, quartz thermometers, and thermometers based on the thermocouples. We can see in the figure 1. Now, in the table 1, listen common temperature sensor and their features. We can see this thermocouple, RTD, thermistor, semiconductor sensors, and quartz thermometers. We have range, high accuracy, and reproducibility, requires voltage comparison on cold junction, and low voltage output for these classes. So let's consider existing serial thermometers from the point of view of their suitability for monitoring temperature fluctuation on the surface of a biological object. We will analyze the technical parameters and the characteristics such as speed and resolution. The most important quality indicators of various thermal sensors taken into account their use in a narrow temperature range are listed in the table 2. The symbol 3+ indicate a high level of suitability for their parameters. 2+ and 1+, respectively, mean and low. From the comparison of the given parameters of the transduced, it can be concluded that the most suitable for the mentioned purpose are semiconductor diode transduced in package design, which have a higher speed. It should be known that pyrometers also have high speed, but their disadvantages include low sensitivity and high cost. Now we can see for table 2 quality indicators of temperature sensors. In slide 5, we can see that the resolution of thermometers is related to its transmission coefficient, since the output voltage of the operation amplifier is limited to the range of 3 10 volt and is a constant value. Expanding the range of measurement temperature leads to decrease in the transmission coefficient and vice versa. A decrease in the range leads to an increase in the slope by the same number of meters. It is important to know that with a limited maximum output voltage on the thermometer, there is a constantly or reproducing the range of control temperature delta T by the temperature to voltage conversion factor U degrees. The specified dependence of the steepness of characteristic for different temperature range is shown in the figure 2. You can see in this slide. Now, the output signals of the thermal sensors different in their conversion function, so thermocool conversion temperature into voltage and thermosensitive sensors change their resistance when the temperature change. There are two types of thermistor with positive and negative temperature coefficient of resistance. Semiconductor diodes sensors are characterized by a decrease in direct voltage when the temperature increases. An evolution of the coefficient of informativeness of temperature conversion of contact thermal sensor in proposed in table 3. The information obtained as a result of measurements is quantitative and serves to evaluate the quantitative data about the studied object or phenomena, regardless of their natures, obtained with the help of chain. Receiver object, measuring device, and the receiver. In our case, Hartley logarithmic measure was used to characterize the quantitative information. Informativeness of the initial parameter in the temperature range of 20-40 degrees percent. Now, it was establishment that the speed of thermometer is determined by the mass of the sensor, since it is by the value of the thermal time contact. Errors illustration this relationship figure 3 for some types of sensors, sensors in different types of package. Figure 4. For example, temperature voltage converted by microchip in a DESSERT'2023 package, a thermal sensor by SmartTech in a TO18 package, thermistor on the NTC company in the DO35 package, of the National Semiconductor company in the TO82 package, and of the Hygress company in the S4.1 package. Thermal time constants term in still air for the housing of semiconductor sensors depending on their mass are shown in the figure 3. For high-speed thermometry, it is necessary to use sensor with a minimum mass, in particular packaged semiconductor diodes and transistors. The second important factor of the sensors which characterize the effect is international self-heating is thermal resistance. Figure 5 show data on the relationship between mass and thermal resistance of several common types of the integrated circuit housing. And conclusions. From the analysis of figure 4, It follows that for monitoring temperature oscillation of the body surface, the most efficiently are caseless semiconductors, diode, and transistors. Temperature sensor with a thermal time contact in the range of hardness of a sensor and the thermal resistance of 2-5 degrees per milliwatt. As a sensitive elements, it is recommended to choose a caseless diode photon or transistor. The dimensions of which do not exceed 1 millimeter with a mass of up to 0.5 grams. As the mass of the sensor decreases, the mass of the thermometer itself decreases, which has a positive effect on the thermal time contacts and therefore increase the speed of the device. To ensure high sensitivity in the temperature range of 20-40 degrees, a diode sensor should be used in the mode of operation with a contact voltage with an output temperature dependent parameters of the diode current. The specified mode of power supply of the diode ensures that temperature sensitivity of the sensor is 5 times higher than when powering the diode with direct current, and the output parameter in the form of direct voltage. So sensors based on semiconductor diode provide high speed, short response time, and operation in the mode of microcurrents, which would maximally reduce the self-heating and the sensor which sensitivity, good linearity, and in a given temperature range 25 40 degrees, stability of electrical parameters. I am conclude. Thank you for your attention.
Valentin, thanks. Colleagues, please, questions. Does somebody have questions? Okay, if no, I will ask one question. At slide 7, you said about some measure called Hartley logarithmic indicator. What is this? Can you explain? Valentin, have you found?
Yes, sorry. Maybe repeat the questions. You might repeat the questions.
Yes, at slide 7 in its lower part.
Yes.
You said about some Hartley logarithmic indicator or measure. Can you please explain what is this? Have you found?
Yes, in slide 7. This slide.
Yes. You see Hartley logarithmic measure. Say Hartley's logarithmic measure was used to characterize. What is this?
We can present formulas logarithmic measures. This formula we can see in our publication. I don't present this. Yes.
Mm-hmm. Okay, and can you say why have you used it? Is it a typical measure? Maybe it was some specific measure just for your purpose.
Specific measure with include temperature of temperature of semiconductors. Temperature of semiconductors. So sorry for my English. I very hard answer the question in English.
Okay, I will try to look in the paper.
Yes, thank you.
Okay, does anybody have some other questions? Okay, then, Valentin, thank you one more time. And I will ask presenters not to take away the presentations just after presenting them, because somebody might have questions just to certain slide. Okay?
Okay.
So
Thank you for your attention.
we have the second presentation, and I see two persons who are the authors of this presentation, Hari Rem and Komati. Yes? Who will present? Komati Velusami, yes?
Yes, sir. Komati will present.
Okay. Please, you're welcome.
Thank you, sir. Hari, share the screen more.
Would it be fine if you guys waited for a second? I'll just quit and reopen the presentation. Just a second would be fine.
We do not see your presentation.
Yeah, that's what I'm trying to say. I just need a second to open the presentation.
2 seconds, please.
Komati, we do not see the presentation yet. Or you ask us to put video.
So let me share the screen, sir.
Yes, please.
Is my screen visible, sir?
It appeared, but then disappeared again.
Oh, okay, sir. 1 second.
Yeah, please. Now we see. Stop.
Yes.
Yes.
Shall we start?
Yes, please.
Yeah, very good afternoon to all of you.
Yeah, please.
Yeah. Our paper title is Prediction of User Ratings for Drug Side Effects Using Deep Neural Network with a Contextual Co-occurrence-Based Word Embedding Vector. And we are presenting this paper in this DESSERT 2023 conference. Myself, Dr. Gomati, and our corresponding author is Hariram and Lata B. So these are the contents of our today's presentation: motivation, state of the art, objective of our research, results and discussion, and conclusion as well as future work. Motivation. The reason why we have taken this as our research objective. Recently, we have that digital informations are publicly available about the information related to the efficacy of any drugs and for what reason and for what cause the patient is taking that particular drug, for what kind of a disease it is being medicated by the doctor, and what are the side effects for each of the drug are publicly available as per the guidelines of pharmacovigilance. So based on that, when we gone through the literature study, we found that there is a patient-driven community being maintained for drug side effect. It means the patients are having the very good knowledge about the causes and side effects of the drug. We would like to quote some of the popular websites like druglib.com and drugs.com. These websites are providing the user reviews on dosage level, severity level of the consumers, and the patient's body conditions. They have an open review format where the patients can popularly provide their feedback about their side effects on the particular whenever they take a drug, they can provide their side effect, what they suffered by that particular drug. And this is coming under the subdomain of adverse drug reaction. It means when a drug is being medicated for a patient, based on their level and based on their body immunity and their other chronic diseases, there are certain adverse drug reactions, and they may harm for the particular patient. So there are a lot of associated alternative medicines are being prescribed by the doctors. So our work is majorly focusing on user rating prediction based on the drug side effect as a text analytics. And when we verified with the literature what are the previous works are being carried out in this particular similar study, we found that there are 5 stages of, 5 hierarchy of works were being addressed. One, the very first and conventional was machine learning based approaches. They were used the support vector machine, conditional random field, Bayesian logical regression, as well as naive Bayes classifier and probabilistic neural network for doing this user rating prediction. And also in deep learning approaches, they have tried with recurrent neural network, long short-term machine, bidirectional long short-term machine, long short-term memory, gated recurrent unit, bidirectional gated recurrent unit, and variational autoencoder for predicting the user rating. And here the input are the drug side effect reviews as a textual passage. And in the textual passage, we were found that the patients were giving about their impact when they were in taking that medication, what was their symptoms in terms of headache, severity, dizziness, something like that. Whatever their internal suffering as well as external suffering, they were being written as a user review. That was the input for this particular work. And even over a period of time, they were much concentrated on the language transformer as it was user defined. There were a variant of data set for the same disease, for the same drug also. Every patient have given different reviews. So they started working on language transformer model called as BERT model, where it is working on the bidirectional relationship between the language in terms of their word vocabulary. Here, the text analytics part comes into a major role. They have used the contextual part of those language relationship to build this BERT model. Especially, they have been given with variant by the researchers, especially BioBERT. They were work on the biomedical data corpus as their input for analyzing the drug review. And then it has been promoted to the level of text analytics as it was a categorical data set. They have collected the feedback from the user in terms of the categorical field, and based on that it has been being associated with the rule mining approaches and disproportionality analysis, where the side effects are proportionated in terms of the drug medication. And as it has similarity with respect to the similar diseases, and sometimes same drug may be medicated for more than a disease, they have applied the clustering technique also for doing the analytics of the user side effect. And there are a few popular model coming in called the auto-generative model, where the partial prediction may be given by the user. The remaining user rating will be predicted by the machine. And based on this wide literature study, we have formulated our objectives for this particular research in the name of to design a novel contextual co-occurrence based word embedding vector with a deep neural network model in order to rate the user feedback about the drug side effect. Our algorithm will be having two phases, one on training that network with the help of the available user-rated data set, which is a passage, textual passage. And based on the training, our model is capable of predicting the user rating at the scale of 1 to 10 for the unknown data sample where there is only side effect passage is there, but there is no user rating. So that is our objective here. So initially the first phase is contextual representation of the given drug side effect passage. When we analyze the input, the size of our input has gone from minimum 100 to 1300 plus words in a particular input. One single record will have the length of the maximum of 1300 plus words in it. And what we did was, as the first phase, those were undergone text analytics in terms of converting them into a stemmation, lemmatization, and removal of article. And finally, we have collected only the core word of the particular side effect sample. And every word is being converted into a contextual representation. That is our first phase, followed by training the network, and finally predicting the user rating as the test phase. So this is the data set what we have followed for our research, and this data set we have referred from druglib.com, and here they have focused on around 40 plus diseases, and for each disease there are number of drug side effect reviews are available, and it is purely an imbalanced data set. You can see in the right corner of the particular slide, the scale shows that the number of ratings, user reviews available for a particular disease. Suppose I take anxiety, there are more than 200 plus records are available with the drug side effect review by the user with a rating. And it clearly shows that our text analytics, basic text analytics will not work as it is an imbalanced data set. So that is why we have formulated our research by embedding the contextual knowledge through deep neural network. And in that formulation, we have proposed our methodology. Here, the contextual layer is our original contribution for this particular work. So what we explore here as the contextual layer is, based on the content available in the drug side effect passage, we found that there are certain contextual, subcontextual regions available in that passage, a kind of a ontology for the drug side effect. And we had taken 10 prominent factor out of those drug side effect, namely the body part, irritation conditions, severity levels, symptoms, pain, alternative medicine, body activeness, doctor's emergency call, is it required for that particular side effect, and chronic effect as well as toxicity. So out of these 10, the doctor's emergency call was much quoted for the ADHD patients. And for these 10 dominant subcontextual field, we mapped the available text word with the contextual layer. So this is our proposal. So based on the co-occurrence of these words and their relativity with this subcontextual word, we have formulated the context co-occurrence word embedding vector. So usually word embedding vector is a very basic concept. After being done the pre-processing, every unique words will be given a vector number. But here, and they will be embedded into a word embedding vector where the sentence will be converted into a number of a sequence of word unique index number. But here we have expanded that with the help of a contextual co-occurrence. So for every word embedding vector, there is a 10-dimensional feature vector, and that vector will give the mapping with respect to the corresponding subcontextual label. If it is not related, the range will be in negative. If it is highly correlated, the range will be in positive. So based on the data distribution sample, we were able to identify the correlation coefficients in the range of -1 to +1. So based on that, we were able to bring for every word a co-occurrence vector based contextual representation. So this is the original contribution of our work. And after that, we had gone through that conventional deep neural network model, which has one embedding vector layer and a flattened layer, and finally the dense layer. So the dense layer will be generating the user rating level from 1 to 10. And we have trained our model with 1200 user ratings, and we have validated with the 344 user rating. And during testing, we have used 1054 sample. And in the test sample, there is no user rating provided as per the data set. There were only drug side effects were given as a passage. So our model will read that passage as an input, and it will automatically generate or predict the user rating. So thereby we could able to meet our objective. So when we did that experiment with that available data sets and the prescription, whatever we have mentioned, we were found the results as we have mentioned here. And the first two columns are the existing work done by the existing research on the same data set. And the last four columns are our contribution. Initially, we have made the three baseline model, which are normally called as a conventional model. We haven't made any contribution over the word embedding vector. We used the basic word embedding vector, and then we implemented over the three language transformer model, where the results were not much promising. Whereas when we changed that into a contextual co-occurrence vector embedding, by enhancing the conventional word embedding vector layer, we were able to find a quite promising improvement in the training as well as the validation accuracy. So the training and validation accuracy are having around a 2.5% gap. So we could able to see the generalization error has been much reduced. And to continue further on the overfitting of the model, we had conducted the testing phase also. We will present for a while. So based on that, we were able to predict the performance of our model by comparing with existing model. Baseline model, we have found that our model has a good performance in terms of classification accuracy, in the sense that as there was user rating available, how far our automated model could produce the same rating, that is the performance accuracy, and loss. So how far it was unable to predict the correct rating. So that is being portrayed here. So the first bar indicate the performance of our proposed model compared with the baseline model. So it has very limited training loss as well as validation loss compared with the baseline model. And we have not stopped at just building the model. The pre-trained model has been undergone a testing over the 1000 plus record for evaluating the performance of the model on the unknown data sample. So here on the pre-trained model, when we have tried our test sample, we could found that it was able to detect the user rating from the scale of 1 to 10, where 1 is there is no side effect, very minimum, very meager side effect. When it is coming at the scale of 6 to 10, the side effect has very sensitive, where 10 is most sensitive side effect. And this graph had made the analysis to understand the severity of the drug side effect. And there are many sample mapped with the rating of 6 to 10. So it is clearly embedded with the passage also. When we had a looking with the passage as well as the rating, it was able to predict the rating in a better way. So this is our prediction for the given user rating. So the outcome, what we are trying to conclude from this particular test experiment is that whenever a user is providing his feedback about the drug side effect, so the pharmacovigilance as well as the pharmaceutical industry could get the knowledge on the severity of the drug side effect for the particular patients. So they can do the analysis over that results, and they can do re-engineering on making a better alternative for those drugs. So to conclude with, we have proposed the context co-occurrence word embedding vector based deep neural network model. and which is capable of learning the drug side effect, and it can match their effectiveness with respect to the user rating at the rate of 1 to 10. And during the test phase, we found that it is capable of bringing out the severity as prescribed by the patient, which is explored by the model with a good accuracy at the rate of 95%. So this is our conclusion of our research. And in future, how we can enhance our research is, as we have chosen only 10 sub-label for the contextual layer, it may not be very sufficient for every kind of diseases and their side effect. We are planning to extend into an ontological network on the basis of the disease, on the basis of the part of the body it is creating the side effect. We could create the ontological network so that there could be a more refined rating and mapping towards the drug side effect analysis, so that for every drug the user can get a heat map as like a body anatomy. Their side effect can be coated over the body anatomy virtual image, so that the user can better visualize the side effect rather than reading through the passage of 1,000+ words. So that is our future plan, what we have. And these are the references we have taken for our work. And thank you for giving us time to present our findings.
Thank you very much. Colleagues, please, you are welcome to give some questions.
Okay.
Are there some questions? Please, you are welcome. Okay, if no questions, I have one question.
Yes, sir.
You said that you have the rating from 1 to 10, yes? And does it means that 1 is a bad drug and 10 is a very good drug?
Yes, sir. Yes, sir.
And you considered probably different drugs. And what is the distribution?
May I get the question correctly? What was our?
What is the distribution of ratings?
Operation?
Is it some normal distribution? Is it some? Does it have some maximum at 7, at 8? I don't know. You have tried.
Scale. Why is it 10? The 10 you're asking, sir?
Okay. What is the most popular rating? Can you say 7 or 8?
This is the user rating scale.
Yes.
That is 1 means mild, no side effect. 2 means mild, very mild. Like that. They have a subjective side effect scaling from 1 to 10. So if it is 6 and above means they are severe. 10 means most severe.
Okay.
Yes.
Thank you very much. Does somebody have some other question? Okay, I do not see. I would like to ask people present at this session to be more active. Okay, so please take away your presentation and let us come to the next presentation. And,
thank you so much. Thank you for the opportunity. Thank you.
And the next presentation will be my presentation, and let me put it to the screen. Please tell me, do you see my presentation now?
Yes, sir.
Okay. So, Let me present our report, which is called Combined Lossy Compression to Frictional Images, that has been prepared by me and my colleague Viktor Makarichev via the Department of Information Communication Technologies of National Aerospace University, Kharkiv, Ukraine. And the presentation outline is here. So, first of all, I would like to say some words about what are frictional images and what are their characteristics. Then requirements to compression. Then a few words about compression based on discrete atomic functions. Then I will give details about the proposed approach to lossy compression. After this, there are a few slides about the results for images of different complexity and optimal parameter selection. And finally, the conclusions will be given. So, there are different types of frictional images. I would like to give 3 examples. First of all, these are conventional color images represented, for example, as RGB data. Another case is medical color images, for instance, retina images. And the third case are remote sensing images in visible band, which can be data from multispectral remote sensing, as example. And 2 examples of remote sensing images are given at this slide. And one typical feature of such kind of images is that they have quite a large size. The image size might exceed several megabytes and even tens of megabytes. And because of this, compression is desired for transmission of such data via communication lines, and as well as for their storage. I would like to remind some basic requirements to compression. First of all, it is often desired to provide high compression ratio with appropriate quality. I say about quality with respect to lossy compression, for which some distortions are introduced into data. Second, compression should be performed quickly enough, both compression and decompression. Third, it is often needed to control quality of lossy compressed images, and this control should be done quite easily in order to provide a desired quality of compressed data. But these are, let's say, general requirements. At the same time, there can be additional requirements. First of all, it is often needed to provide privacy of compressed data. In particular, in medical image compression, it is desired to somehow hide information for patients, you know about this. Next, it is desired to have different compression options, lossless and lossy. I will tell a little bit about this later. Then, it is often needed to save power needed for compression, especially if compression of remote sensing data is carried out on board of drones, on board of UAVs, and so on, because power is limited in this case. This also has a relation to the so-called green technologies. That is, we have to save energy and not to irradiate into the space around us. So, some words about discrete atomic compression. It is, in general, it is a lossy image compression algorithm, and it is based on atomic functions, which are specific type of wavelets. Discrete atomic compression provides better compression than JPEG, and even better compression with some other modern compression techniques under condition of the same quality of compressed image. And what is also a good property of discrete atomic compression is that privacy protection can be integrated just into compression due to use random and unknown to other person configuration of blocks. Here are some papers where you can find details about discrete atomic compression. And let us look at the structure of compression based on discrete atomic function. So it is, let's say, quite typical. We have RGB matrix, or let's say frictional image. We perform RGB to YCRCB conversion. Then we apply discrete atomic transform. After this, having coefficients of discrete atomic transform, we carry out quantization, and just at this stage we introduce distortions. And after this, we can use Huffman codes, a run length coding, or some other method of coding the quantized coefficients of our transform. The compression is in inverse order. That is the coding, the quantization, inverse discrete atomic transform, and the conversion from YCB, CRCB to original space. What we propose and why do we propose this? It is often desired to have both modes of compression, lossless and lossy. For instance, you know that JPEG has JPEG LS and other known standards also have lossless and lossy compression modes. And our idea is the following. Let us get a lossy compressed version and then calculate a difference image and compress difference image in a lossless manner. In this case, we have DAC file that has header. It has the main part, and this is the part that corresponds to lossy compression. And then we have also the extension, and it contains compressed differences. Due to this, we can first get a lossy compressed image, and if this lossy compressed image does not satisfy us because of several reasons, then we can ask, okay, please get the extension, and we can get a lossless compressed image. Concerning compression based on discrete atomic functions, we have to say that there is the parameter called UBMET that controls compression. So setting a larger UBMET, we get more distortions introduced, and at the same time more a larger compression ratio for lossy compression. And for this case, we have earlier considered compression results for a large database of frictional images provided by European Space Agency, and the following results have been obtained. So there is optimal point that corresponds approximately to UBMET equal to 63, and arithmetic coding applied to differences, it performs better than Huffman coding and run length coding. And you can see that we have a certain benefit compared to zip coding, for instance. But at the same time, these are average data for a large number of images. But at the same time, the question is the optimal the same for any image? And this was the main question in our study. So we considered several images of different complexity. Here are the results for images of complex structure. And for images of complex structure like this presented at this slide, at this image. So, and we also have analyzed 3 versions of compression based on the discrete atomic transform. This is classical version, DAT with block splitting, and DAT with chroma subsampling. 3 different approaches, and we have compared them. So the conclusions concerning complex structure images is the following. Like for classic DET and DET with chroma subsampling, they produce similar results in terms of lossless compression ratio. Lossless compression ratio is in the last column. At the same time, classic DET produces better PSNR, peak signal to noise ratio, and mean absolute deviation, but it produces slightly worse lossy compression ratio. And one important aspect is that lossless compression ratio is practically the same for UMET equal to 63 and 95. So we have a, let's say, quasi-constant region of UMAT, and we can take UMAT from this interval. At the same time, DET with block splitting, it produces worse results than two other considered modes. Because of this, we can say that for complex structure images, it is worth using classic DET version with a MAT about 90. And this selection, this recommendation, provides a reasonable trade-off between the quality loss of compressed images and the compression ratio for lossy and lossless modes. The next part of our study deals with simple structure image, like this image. And we say that this image is simple structure because it contains a large portion of homogeneous, of pixels belonging to homogeneous regions. And in this case, the situation is slightly other. Classic DET and DET with chroma subsampling again produce similar results, but at the same time, DET with block splitting produces the same results as classic DET, and here you can see that it produces larger compression ratios. So we can recommend to use DET with splitting with UMAT about 150, since it produces a reasonable trade-off between quality of lossy compressed images and compression ratio for both modes. A question is how we can characterize complexity of images. One way of characterizing complexity of images is to use entropy as parameter able to characterize image complexity. Then we have analyzed the obtained results and it occurred that for complex structure images, lossless CR can be about 1.25 and lossy compression ratio from 2.5 to 5. PSNR is about 35 dB, and this is at the edge of distortion visibility. Meanwhile, for simple structure images, lossless CR can be up to 2.7. That is considerably larger than for complex structure images. Lossless CR can be about 15-20, and PSNR is about 42 dB. That is introduced distortions are invisible. And we would like to change in the future, we would like to design an adaptive method of complexity characterization based on entropy or some other parameter. Then we have also analyzed what is computational efficiency. Here are the parameters of our computer used in this case, and the conclusions are the following. For images having tens of megabytes, tens of gigabytes, the computational efficiency is high enough, and the compression and decompression take only a few seconds. The compression is faster than compression, and one more conclusion is computational time is approximately linear proportional to the image size. You see that for an image of about 100 of megabytes, we need the largest time for both compression and decompression. So finally, what are the conclusions? We have proposed and analyzed the combined loss approach to compression color and free-channel images, and have understood that it is practically the same, almost the same what UMAT to set, but setting a larger UMAT, we can provide a larger compression ratio of lossy compression. We have given recommendations of parameter settings, and we have also compared our method with zip, RAR, and PNG. And the results are that our method provides practically the same efficiency of PNG, the compression level 9. Some details concerning computational time are given, and we can see that our method is fast enough. Thank you for your attention, and you're welcome to have some questions to me, please. Colleagues,
I think that everything is clear.
okay, if no questions, then we can come to the next presentation. And the next presentation, let me see, Ibrahim Didmanidze, Darajan Yaladze, Volodymyr Zaslavsky, Zebur Beridze, Ketevan Zaidze, Iya Matskabili, Diana Akhlidiani, and Inga Sormanidze. Who will present this paper? Dear colleagues, are there some presenters of the paper number 4? I'm sorry, one more time. Are there some presenters of the paper number 9338, Development of Technological Competence for Digital Educational Activities? Okay, if we do not have presenters just now, let me ask them a little bit later. And the next paper, Gia Serbiladze, as I can see, you're here. Yeah.
Okay. Hello, dear colleagues.
Yes, please.
And we are opening our slideshows. Yes.
Yes, yes, please.
Sure. Do you see or listen me?
Yes.
Yes.
I hear to you, and we see. Please, yeah, you're welcome.
Okay, I'm starting. Yes.
Yes, please, please.
So it may be make more dimensional. Yes.
This is better.
Yes.
Okay. So welcome to participants of this session of our conference thank you very much to organizers of this conference for our invitation to this session now on our speech. So we'll consider today multi-attribute decision-making interactive model based on the well-known body of evidence theory and fuzzy discrimination hybrid approach for the creation of dependable and reasonable applications. And we'll consider as an example application of our approach in emergency psychiatric diagnostics. So so it is very important timely servicing demand points and persons which are in the disaster-stricken zones, disasters which maybe happen by some natural catastrophes or on the results of hostilities and so on. So the basic in these problems is logistic planning problems and medical emergency medical planning problems and other things. And in the whole service, the timely servicing is very important. We'll consider some new approach method for the creation of dependable intelligent supporting systems, which may be applied in emergency psychiatric diagnostics for the victims, which are in such as regions in recovery phase of the planning of emergency problems. So a new interactive math approach based on evidence theory and fuzzy discrimination analysis is developed. Multi-attribute decision-making utilities or expert evaluations will be presented in so-called Kurang orthophobia fuzzy values as some extensions of Zadeh's fuzzy sets theory. This presentation will be involved in the Debster-Schaeffer belief structure environment and Debster's external expectation and as an aggregation instrument for the ranking of optimal, for the ranking of all possible alternatives or the selection of optimal alternative under discrimination, Kurang orthophobia fuzzy information also will be developed. So extending a numerical example it will be presented in the problem of emergency psychiatric diagnosis. So the speech will cover the following main problems on attributes interaction phenomena in such as problems. Usually when we have several attributes in decision-making problems on which some attributes or state of nature acts in the decision-making process, it is sometimes we have such as cases where these attributes are in the interaction environment. So these phenomena will be considered for in the process of construction of decision-making models. Debster-Schaeffer belief structure. Debster-Schaeffer belief structure is some extension of probability statistical theory on the one hand, and on the other hand, of the so-called possibility theory by Zadeh and other authors. And we have some extensions of this method of this theory in the temporal environment. So we don't consider temporal case. We consider only static case of Debster-Schaeffer structure. Sometimes which this theory is unique in the evaluation process of complex nature problems investigation, where the unique information source is expert and her knowledge. So new extensions of Debster's external expectation as an aggregation operator also will be developed in the environmental Dempster-Shafer belief structure, and attending numerical exam will be also considered in the environmental emergency psychiatry diagnostics. So our goal was to use Dempster's extremal expectations as an aggregation tool in multi-attribute decision-making models. Let Phi Psi will be some pair of Courant or Hopf fuzzy numbers. If in Zades fuzzy sets, we know that we have only single levels of uncertainty. In such a case, we have as two units, and the first phi indicates of the assignment in the membership of degree, and the second phi indicates on the non-membership degree. But by the following inequality, this inequality has some freedom in the selection or the choice of these two pairs, where Q will be some minimal number which satisfies this equality. It is clear that this form of presentation of expert activities in the process of solution on the evaluation of possible alternatives with respect to some attributes will be more convenient because we'll have here more intellectual activities using Courant-Hopf fuzzy. Courant-Hopf fuzzy sets theory is developed today and is very applicable in such as problems. So let me consider in general some multi-attribute decision-making model where we have some sets of alternatives, some attributes, also from the provides historical data that we give also frequency data for this for the all alternatives with respect to some attributes by phi G's. So we have some matrix by frequencies by named decision-making matrix. So from this matrix, we transform this data to the so-called positive and negative discriminations measures, P and S. What is the P? In this formula, CD is a cardinality of the attribute sets, and the gamma ratio is a fuzzy value which indicates on the fuzzy arguments value, and we have the following information hence of these two parameters. In whole, this pair creates some Courant-Hopf fuzzy sets. The main is that it is necessary to mention that this pair is more convenient and more information than only frequencies, and attributes interaction phenomena is included in the such as pairs. So on the information has on this pair. What is a positive fuzzy discrimination? This method describes the degree of confidence that the attribute I is more relevant, indicative of the alternative G than any other attribute. But negative fuzzy discrimination indicates that this measure represents the belief, not degree, but belief that the attribute I is less relevant, indicative of the alternative J than any other attribute. So instead of the frequency matrix as a decision-making matrix, we consider matrix as a decision-making matrix by these Courant-Hopf pairs by set by D, the Descartesian product. So by the transformation and interaction phenomena between attributes are reflected by the constructed fuzzy discrimination Courant-Hopf fuzzy numbers. So sometimes the interaction of attributes is the basic, and we have to consider such as multi-attribute decision-making models when an aggregation instrument only has the possibility to consider this phenomenon. Okay, now shortly on our algorithms based on the Depth-Schaeffer belief structure. You know that from the statistical probability theory, we have mass or some frequencies or elementary probabilities on the elementary events, if we consider finite case of probability theory, okay? But sometimes in complex environments of the experiments, not random experiments, we have such situations where not single electrons, but some subsets of events can some information with respect to possible data, possible analysis, or possible alternatives. So this mass is called in this theory as the focal probabilities. And if this focal elements as which has some information by strongly positive masses of so-called focal probabilities, if this pair is called Depth-Schaeffer structure, where these BGs are singletons by its probabilities. In this case, we are in the probability environment. Sometimes we are in the possibility theory environments. Sometimes we are in the hybrid environment. So in general, when our evaluations or statistical samplings are based on the knowledge experts' evaluations as a unique source of information, in such as cases, not probabilistic, but Depth-Schaeffer belief structure is a unique instrument or unique possibility to describe informationally, quantitative informationally, this process with respect to decision making. So let me give some in our problem some Depth-Schaeffer belief structure by M and B focal elements. So we consider now the skill. Now we consider skill 1 by the following steps. Create decision-making matrix based on frequencies of the previous history in fuzzy discrimination decision-making matrix as a Courant of fuzzy numbers matrix. Create a focal elements which have some information in the mass as a focal probability in our problem. So we consider only focal elements, some sets of our states of nature, which has only strongly focal probabilities, okay? On the following step, we determine the weight of each attribute and weights of focal elements. On the following, we build the unity collection as a set of frequencies on the focal elements. After this, we select some aggregation operator, and by this aggregation, in the aggregated benefits, we aggregate information of this frequency sets. So calculate the expected predictive value. We calculate CGs as a weighted sum of the aggregated benefit by the weights in the row of weights. We'll use focal probabilities. And the end step, we rank alternatives from the optimal to the less optimal by their discrimination values, CGs. So this is the simple presentation, simple case of our approach, how we can select optimal selection based on the Depth-Schaeffer belief structure. The freedom in our procedure is how we can aggregation function. Now we go to on this problem. So in this presentation, I define so-called Dempster's extremal expectations. The upper expectation, DLE, the lower expectation. Please, it is necessary to mention that this is some weighted sum on the focal elements, frequencies, or utilities values by weights, the focal probabilities. It is clear that for every decision or for every alternative, this pair creates some orthophase number. Let us construct an extraction of these aggregation operators in the discrimination environment. And this discrimination will be the new presentation in which will be presented attributes interaction. And this extension will be good aggregation instrument when in decision-making problems always exists attributes interaction. So this extension presented by these two formulas for the DUE will be extension by the large ratio function, by mass or focal probabilities, and they have the pessimistic, optimistic ones, extensions, or lower and upper expectations of themselves. So now on the application or constructed our scheme, when in the role of aggregation we will use Dempster's expectations and its extensions. So we will have two possible aggregation results in the prediction of diagnosis of some patients in future. Now we go to on the ending our problem of my presentation, application of these two expectation aggregation tools and their extensions in the emergency psychiatric diagnosis. So the population affected by the disaster has many problems, yes. One of them is quick medical assistance. Among them, there are many psychiatric disorders caused to citizens in a stressful environment. Early groups that are recruited to help the population may not include qualified psychiatrists. In order to create the necessary preventive diagnostic environment, appropriate supporting medical diagnostics, dependable and resilient emergency decision-making intelligence system must be able to reduce the number of victims, not number of victims, also maybe reduce some materials and other resources of this environment. It is necessary to construct tools for effective aggregation of interactive attributes of different types of decision in order to make extremal optimal decisions. It is clear the software based on our approach technologies should be involved, which will be focused on minimal medical examinations. So our developed methodology can be considered as a model of such a support system. We will consider the example of emergency psychiatric care in an extreme situation using the decision-making model built in this work. So we consider based on some previous historical true decisions dealing with the or alternatives as a psychiatric diagnosis. Let's consider three such as alternatives here, and this and possible attributes as symptoms we'll consider here, and these are some frequencies which are calculated based on the information from the information center of the State Psychiatric Clinic of Georgia. So based on this decision-making matrix as a matrix of frequencies of true decisions to diagnosis with respect to activities of symptoms is considered. So on the basis of this expert's information, we created some focal elements by the symptoms which individually act on the possible decision or on the possible diagnosis. So we selected such as way only for such as types of focal elements, where some symptoms are included here, and maybe some symptoms may be included in several symptoms. So maybe these focal elements may be jointed. And we have also, on the basis of their experiments and experience, weights of these symptoms. And after this, we evaluated focal probabilities of focal elements. So in general, we created the Depth-Schaefer belief structure of such a time of problems, and now we consider, based on this knowledge information, we consider some disaster region and some persons which are included here. And for this, we consider everyone from this as a patient. We'll consider some activities of our method for the make optimal recommendation as a optimal diagnosis selection. So let's consider the patients from some victims. For these patients, all presented groups as focal elements are characterized symptoms groups. Otherwise, we have to take in the decision aggregation scheme only such as focal elements which are characteristic for the concrete patients, or such as focal elements which act on the decision process of decision-making selection. So table 3 shows the calculations obtained by the two methods of aggregation described above, and the rank data of optimal diagnosis for these patients. So we have here that if we use standard or classical pair of Depth-Schaefer expectation, we have the following ranking, and the F20 diagnosis is more optimal than another. Also, for the extension of these expectations by our aggregation operators, also is ranked this diagnosis, and in this case also this F20 diagnosis is optimal for this patient. But now we on the comparison of rankings. As we can see, the optimal diagnosis in both aggregation cases is paranoid schizophrenia, so F20 0. However, second and third order diagnoses are different from each other, and this indicates different approaches to aggregate it. See, please. So second and third, the second and third levels of diagnosis, we have some differences. And as mentioned above, this difference is due to the existing of the phenomenon of interaction of symptoms as attributes of the model. So, understanding, it is clear that for each patient whose data and expert evaluations will pass the scheme creates above, it will be possible to predict the diagnosis in the environments of the constructed scheme, but taken into account only such focal elements which are characterized for the concrete patients. At in conclusion, in this work, the phenomenon is reflected in the fuzzy discrimination parameters introduced in the Depth-Schaefer belief structure environment in the aggregation of Depth extremal expectation. The difference of the new aggregation from the classical Depth aggregations of extremal expectations is presented in the numerical exam from diagnosis of emergency psychiatry. In order to develop future studies, the fuzzy discriminations will be embedded into such aggregation operators which take into itself account attributes interaction phenomena. For example, socket aggregation integrable or pseudo integrable environment, and so on. Thank you very much for your attention. So, questions, please?
Thank you for your presentation. Please, questions.
Yes.
Does somebody have questions? So I do not see. So I do not see the presenters of the fourth report. So my question to Professor Serbiladze is, are you ready to give the last report at our session just now?
Which slide?
No. I mean, are you ready to give the next report?
Yes, of course. Yes. Okay. No questions.
No, it seems to me no.
No questions. Okay. Thank you.
Thank you.
Just a minute, please.
Yeah, of course. We have time since there is no one presentation. Are you Bejan Gvaberidze? Yes?
No, I'm Bidzina Midodashvili. Our author of our paper presented on your conference. Do you see the slide?
Wait for a moment, please. Yes, I see the slide. Yes, please, you're welcome.
Okay. Can we start?
Yes, please.
Well, so, thanks for invitation to the conference. I am Bidzina Midodashvili, and I'm pleased to present the work titled Dependable and Resilient Emergency Multi-Attribute Group Decision-Making Approach for the Selection of Humanitarian Aid Distribution Centers. Nowadays, special attention is paid to the engineering of dependable and resilient intelligent systems and models. This direction includes also multi-attribute group decision-making models and systems in emergency environment. As a rule, this environment is characterized by insufficient objective data and lack of response time to solution of the problem. We consider in this direction a new multi-attribute group decision-making of facility locations selection problem, FLSP, based on the TOPSIS approach. TOPSIS stands for Technique for Order Preference by Similarity to Ideal Solution. Well, usually facility location selection problem models designed for extreme situations can be used during the delivery of humanitarian aid in the affected regions. For relative simplicity, we consider only one direction of these problems, namely selecting the location of humanitarian aid distribution centers in the case if we have the disasters like earthquakes, floods, terrorist attacks, or other disasters. So, location planning for potential distribution centers is critical because of traffic congestion and, of course, other problems that arise from transportation facilities under extreme conditions. The increasing number of cargo shipments has a negative impact on the local population and the environment. Of course, the local municipal administrations use stable rules for cargo transportation, such as time, limiting delivery time, special delivery zones, special rules, and so on. So, with the introduction of these rules, logistic operators face difficulties, of course, when planning the location of service centers. Planning of location of service centers in a specific situation is a much more multifaceted problem that requires taking into account many attributes of an uncertain nature, such as the maximum scope of service to the customers, the minimum cost for service, the minimum impact on local residents and the environment, as well as the response to the rules of cargo shipment, and so on. Let us consider the fuzzy TOPSIS approach for selection index of a candidate humanitarian aid distribution centers. When we consider decision-making problems under conditions of incomplete information, we have conflicts between information uncertainty and inaccuracy. And in order to increase the accuracy and reliability of decision-making, along with objective data, we have to also to take into account subjective data from experts as well. Yes. In such a case, the correct selection of semantic forms of expert data becomes important. In this work, we focus on Q-rank orthopair fuzzy numbers. Suppose that we have locations of candidate humanitarian aid distribution centers. We denoted CS. This is the set of candidate sites. And these locations are known beforehand. And suppose all attributes which determine the selection of candidate sites is the set omega. These attributes may be as, for example, access by specific transport modes to the candidate site, security issues of the candidate site from malicious actions, and so on. Different costs, certain impact on location of location on the environment, and so on. Let us also suppose that these attributes have weights given by set W. And suppose that we have T experts, expert 1 up to expert T, invited for making some evaluations. And suppose that also that case expert evaluation of case expert with respect to the attribute omega j on the candidate side I is denoted by Q-rank orthopair fuzzy number Xijk. For each expert, we provide binary fuzzy relation Xk. This is this set, as you see here, and this is a decision-making matrix with elements given in Q-rofts. Of course, if the attributes may differ from each other, one may be of cost type and the other may be benefit type. So here we use also conversion between them. The data from experts should be aggregated in etalon decision-making matrix, one matrix. And we are building the fuzzy TOPSIS approach, which will allow aggregating objective and subjective data for every candidate site into numeric values. This is the selection index for candidate sites. Formally, the aggregation can be thought as the TOPSIS relative closeness of the alternative on Xij. Here is the formula. Beta E, this is the index, and it is the value of TOPSIS aggregation on this row of evaluations, candidate site evaluations. Let us consider the ranking scheme, how we should rank these candidate sites and choose the better optimal from them. Here are some steps. Step 1, selection of location attributes. It is connected with the selection of location attributes for assessing potential locations for candidate sites. As we take the key attributes such as post-disaster access by specific transport modes to the candidate site, post-disaster security of the candidate site from malicious actions, post-disaster connectivity of the location with different type of transportation, different costs of transport, resources, products, and so on, certain impact of the candidate site location on the environment, proximities of the candidate site from the central location. These are the key attributes. Selection of candidate sites location. It is connected with selection of locations for the placement of distribution center. Using knowledge, prior experience, and certain aspects of the geographical area of the extreme events, the decision makers should identify locations for placing service centers. Of course, if the municipal administration has some restrictions on certain areas, they are taken from consideration, and this is okay. Some details. Preferably, potential locations should serve the interests of each city stakeholder, such as citizens, municipal administration, and so on. Step 3. Assigning Kurov ratings to attributes relative to candidate sites. Suppose that each expert, for each expert, there is a fuzzy binary relation given by matrix of ratings made by experts, and here Xij K is the rating of the candidate site, CSI against with respect to attribute omega j. Next, step 4, in this step we should choose the common Q-rank for all assessments. This means to find positive integer number such that for each assessment, these inequalities should take place by formula 2. Step 5, construction of an etalon Kurov decision-making matrix for candidate sites with respect to attributes. Assume that the experts' weight ratings are given, each expert is evaluated itself, and these ratings are numbers, positive numbers, C, K, and their aggregated overall ratings is defined as the weighted sum of their ratings by formula calculated by formula 3. So the matrix of the relationship constructed as a reference decision matrix has the form given in formula 4. This is. Of course, here also we calculate the values of function score and accuracy. These are calculated by components of Q-rank orthopair fuzzy numbers. These are the ratings, C, I, J. And step 6. Here we should identify the Q-ROF positive ideal solution and negative ideal solution. Here we choose the maximum values ratings in columns, and they have such a by such condition we can be chosen by these two conditions. Of course, in real life, these are infeasible alternatives: positive ideal solution and negative ideal solution. Step 7. We have to calculate proximities, distances between the alternative candidate site location and the Q-ROF positive ideal solution with Q-ROF negative ideal solution. So the distances are calculated by formulas 5. By formula 5. This is the Q-ROF in terms of Q-ROF operations, arithmetic operations. Step 8, calculation of the relative closeness of top-6 aggregation as a candidate site selection index. Generally speaking, the bigger distance from candidate site to negative ideal solution, and the smaller the distance between this candidate site and positive ideal solution, then this alternative for the selection is better, of course. In the top-6 method, we introduce new or some modified formula for relative closeness, and this is the given by formula 6. Here, small and large are functions, and they may be chosen such that they should be strictly decreasing and or increasing fuzzy values on given interval in the segment 0, 1. And we, in our calculations, we choose such values. Step 8, ranking of candidate sites for the opening by their selection index. We said that candidate site CSI is more selective for the opening than candidate site CSJ, and write this relationship if and only if beta E is greater than beta J. So now let us see the work of this algorithm for numerical example. Here we demonstrate the situation with 5 humanitarian aid distribution center candidate. The number of candidate sites are 5. Suppose also that the attributes is also 5, for example, and we choose omega 1 is accessibility, omega 2 is security, omega 3 is connectivity to multimodal transport, omega 4 is costs, and distance to customers, proximities. Well, suppose that the experts generated attribute weights based on the principle of consensus as attribute importance levels. Here are the given Suppose that the experts have its weight ratings similar, for example, and so CK is 1 divided by 3. And also suppose that each expert has made ranking estimates for every candidate side E. And here these are evaluations and these ratings are given by these tables from expert 1, from expert 2, from expert 3 evaluations. And we should aggregate these in one table. The ratings of all 3 experts are aggregated in one table. We ran all above data on the new fuzzy top-6 algorithm, and we obtained the top-6 estimates for candidate center selection indices, which are the values of them are as given here. And so the candidate sites are ranked in this way. And of course, it is obvious that the best candidate, how we can choose, is in this order. Candidate C is second candidate site, then fifth, then fourth, then first, and then third. Well, in this work, so we can say that new fuzzy model of object placement is developed in extreme environment under uncertain conditions. Experts evaluate each candidate humanitarian aid distribution center with respect to uncertain attributes. And top-6 method is developed for the formation and representation of expert knowledge on the planning parameters of emergency service facilities. In this approach, we propose a score function-based comparison method to identify the curve positive ideal solution and negative ideal solution. And for illustration of this, everything of this, we consider a numerical example. From the practical perspective, the more detailed constraints and maybe more complex constraints to the problem are supposed to be developed in our future research, and use also different other semantic forms for these problems. Thank you for your attention.
Thanks. Are there some questions? Dear colleagues, are there questions? And Professor Medodashvili, thank you very much for your presentation.
Thank you.
And we have given possibility to give talks to all presenting participants, but unfortunately, one paper is missed. Maybe it can be presented at some other session. So maybe some problems appeared. I don't know. I would like to ask our Georgian participants to somehow manage this. Okay.
Okay. Thank you.
Call and ask what happened and what can be done. So thank you very much for participation. Our schedule is over. I would like to thank all the participants of our section, and I would like to wish you all the best in the future, new results, new cooperation, new successes, and so on. So thanks and good luck in everything.